Hello everyone, wherever you are. Welcome again to this another lesson. Yomwe tufuna activities from where we had stopped from the previous lesson. Yomwe mongo kumbusana in the previous lesson tinaona kwena kuti electrolysis imachitika motani kakhakwena kuti ndi the ionic compound komano which is in a modern form, and tinaona makamaka in the case of lead bromide, right? What happens and all that. So in today's lesson, I just want us to continue. Now we're having the same electrolysis, but then tikukhala ndi an aqueous ionic compound. In other words, we have an ionic compound, right? For example, in the case of sodium chloride, right? Or it could be the same thing, lead bromide, in the previous lesson. Komano yonena kuti yapangidwa dissolved yasungunuridwa mujani mumazi. Okay, so what really happens, that's why we're having the aqueous ionic compounds. And if you remember quite well, tinapanga so kunena kuti if it is dissolved mumazi, mazi amakhandi ma ions yake, like the hydroxyl ions kumaso amakhandi ma hydrogen ions kamena kuti ma protons, right? And if we were to introduce another ionic compound, it means kwena kuti apapakhala kwena kuti pali ma ions osiyana ochuluka sopano in the same solution. You get the point? So tufuna tuone kuti sopano chimachitika ni chani, cause pajava zinali like a giveaway kwena kuti kuti apezapo chitsulo kwena kuti apezapo gas. That was it in the modern form. Komano, it's not the case with the ionic compounds that are in an aqueous form, or the ones that have been dissolved in water, right? Then whenever, for example, in the case of sodium chloride, okay, which is an ionic compound, whenever this one dissolves in water, right, my ions are color free, like in the case of chloride ions and also the sodium ions. Those ions will be like floating. They will be free there in the solution, right? Manjila they can be decomposed, they can be electrolyzed, and as much as electric current is passing through it, they will be split, they will be decomposed in a way, right? However, for you to determine which compounds or which products will be formed from different electrodes, like there must be some other considerations, because you can't just easily tell to say ababa tikandi, let's say lead, let's say to the cathode, and then tikandi the bromide gas, bubble off, something like that. Command in this case, it's really hard for you to tell though in terms of the products. However, the products are usually different from the products of the electrolysis from the modern ionic compounds, because ababa there must be some other things that need to be taken into consideration. This is so for jonena kuti tina pangapo kale introduce kwena kuti water naiso imakhandi majani ma hydrogen ions komanso makhandi ma hydroxide ion kamena hydroxyl ions. Mwanjira ina sungangonena kuti apapa ndi kuti tikhala ndi sodium mbali yawo kwina kuti peza kuti akhandi chani let's say chloride amene akhale kwena kuti in form of a gas apanga bubble of no. Komano tikufunika tuone kuti so what are the things that will make it kwena kuti fail to zero kamena kuti tipange foretell kwena kuti I think from this cathode this is what we're going to have, in as much as this has been achieved. I think we're together, right? Then ndipamene tikupeza kwena kuti mumadzi, yes, of course it's not madzi onse komano just a tiny portion of it, like madzi ochepa, ma molecules ochepa amapezeka kwena kuti mumadzi muja akupanga split in two ions. So it's not kwena kuti izi ngati mene zimachitikira mu sodium chloride, kwena ku sodium chloride has to split sodium and chloride ions. Komano madzi si onse, yeah, just a tiny portion of it, but still more, even though it's a tiny portion, it has got an impact when it comes to the product formation on the electrodes. So we need to dive into that. What really happens kuma electrodes, and tita ku kala ndi chan if tikupanga this electrolysis, and how can you tell? So we need to pay a closer attention to this as well, because they're more examinable examinable, and mafuna angoona kwena kuti kodi niyo muku ziwa ma principles zake wena kuti this is the product that is going to be formed, because we have the other thing, or we have the principle of preferential discharge and all that. Okay, so this is just the equation yomwe funa ituonesere kwena kuti since we have the ionic compound which is dissolving in water, and then the water molecules, we have H2O, right? The water molecules are going to split into, we have H2O which is in form of a liquid, and then we have protons kapena kuti hydrogen ions amene akubwera komano because they are in water, it's no longer L, it's aqu, meaning aqua, right? It's aqua. Pamene kwena kuja pamene timaona lead chan timaona kuti it's liquid because there was no water there, right? So we need to at least try to differentiate kwena kuti kodi this thing the modern. So it's an aqueous form. Even the hydroxide ions are mujani aqueous. Mwanjira ina, we'll have sodium which is positive, and we'll have hydrogen ion which is positive, and then we'll have chloride ions which is negative, and then we'll have the hydroxide ions that are also negative. So these are the things that will be competing in the same solution, right? So in terms of the products, what are the things that we need to take into account? I think this is it that is gonna come up, okay? Or this is it that we're gonna have in the end of this whole reaction. So in the aqueous solution, even ma ions auchokera kumadzi amapanga compete, right? And now also amafuna apange receive, komanso amafuna apange give my electrons, because all of them are positive and ions and negative ions as well, right? So now also amakakuta kupanga now compete. So to predict this, for us to foretell kwena kuti uyu ndi amene awine, and at this electrode we're gonna have this product instead of this product, tukufunika tiziwe ma rules. So there are some rules which we actually follow. Kuti ife tipange predict, kuti ife tipange foretell, kwena kuti this is pretty much what is gonna happen in the end of this whole reaction of electrolysis, okay? And as far as the products are concerned. So, chomwe tikupanga ndi chani? At the cathode, okay? So, let's see the difference between this one, the modern form, okay? At the cathode, remember, this is the one which is connected to the negative terminal, right? Where pamene timaona nkhani ya lead bromide and stuff, ndi pamene kumabwera lead, right? Amabwera kumene kuchako, a metal. Komano apapa chomwe chikuchitika ndichoena kuti it is dependent on the reactivity of that metal. Because if you were to go back ku nkhani ya ma oxidation reduction reactions, okay, those ones, ndipamene tikupeza kwena kuti those ones tinabwera ndi reactivity series, okay? So that reactivity series, if you were to look at it and then you find out kwena kuti this metal which is in this solution is more reactive, right? If a metal is more reactive than hydrogen, because remember all of them are positive ions, right? So if that metal is more reactive than hydrogen ions, the ions ya metal ija imangotsala mujani mu solution, and it is the hydrogen ion yomwe imapanga accept the electrons kujani ku that cathode, okay? So this is not just simple and straightforward from menizima kaida kujani ku the modern form ya lead bromide, because lead bromide lead, since it's positive, it's going to be, you know, receiving the electrons from the cathode, since, you know, the electrons are moving from the negative terminal of the battery and then it's going there. But then apapa zikubwera mwena kuti it's dependent on the reactivity of that metal. If it is more reactive than the hydrogen, the ions will just stay there in the solution, and it will be the hydrogen ions zomwe zikakhale kujani ku cathode, and it will be receiving those electrons. And because of that, since hydrogen samango panga exist in form of hydrogen like H, no, it has to combine with another hydrogen to form H2. In other words, tikandi hydrogen gas. And mwanjira ina, at that cathode electrode, that is, tikhala tikuona some bubbling off because that's hydrogen gas, right? But then if you were to go back to the reactivity series and then you find out when that metal is less reactive than the hydrogen ion, ababa ndi pamene angawine sopano. So if you have the metal yoyena kuti is less reactive, and mwanjira ina those hydrogen ions are the ones that are more reactive than the metal itself, that metal ndi imene ipange win, and it will go to the cathode and accept the electrons, and because of that the metal will be forming at that cathode monga inachitikira to the lead, right? Komano these hydrogen ions will stay in the solution. So if you keep that thing at the back of your mind, I think that would be a very good good start, because in that case what will happen at the cathode, depending when we have this we have the reaction like in the case of sodium chloride, or it could be lead bromide in aqueous form, and when lead in that reactivity series, if it is more reactive than the hydrogen, okay, I think it is the hydrogen that will accept the electrons at the cathode, and then obviously there's going to be the bubbling off and all that. Okay, if it is less reactive than the hydrogen, obviously the metal will be formed at the cathode because this will receive the electrons, right? So tikakhala kuyena kuti sopano taona yes on that side the cathode, okay, what happens on the anode side? Okay, what happens on the anode side coming with the positive side? So because anode is positive, okay, it's positively charged like the electrode itself. So is kupanga attract the halogens, the halide ions, right? So you can talk about the chloride, you can talk about the bromide, you can talk about the iodide, something like that. So the thing yakuma anode, they are not dependent on the reactivity monga from the reactivity series, right? Komano, they depend on the concentration. So here is the gig. If it happens to say yes, there is that chemical reaction that is happening, or there is that electrolysis that is happening, but then the electrolyte which is there in aqueous form halide ions, and those halide ions are in sufficient concentration, ilindi concentration yokwanira yokutala ngakuti yokutala, okay, yambiri, okay. Those ones, if the concentration ndi yambiri yokwanira, those ones will be the ones to give up my electrons than the hydroxide ions, okay. So concentration yama, let's say chlorides in this case, because we're dealing with the sodium chloride which is in aqueous form, right? And because the chloride ions ali concentrated in that solution, that chloride ion azipita ku that anode, and they'll be releasing those electrons rather, right? They'll be giving away. Mwanjira the hydroxyl ions will be just there in the solution, whilst this other one, since it's a halogen, is basically when we are also forming like gas, something like that, right? Komano, if it happens to say those ions are halide elements, akupeza kwena kuti ali osungunuka, ali diluted, kamena with the concentration sili yambiri, amene aziwina ndi hydroxyl ion, kamena kuti hydroxide ion, okay. Mwanjira ina, this hydroxyl ion azipita ku anode kujako, and because of that azipanga release ka electronic kake ka negative, azipanga release, and that electronic kakuti kupitira bwino kupanga complete the whole circuit as we know, right? And because of that akakhala kwena kuti wa lose this electron, okay, the whole thing yomwe amakhala akubwera nacho ndi oxygen. So pakhala kwena kuti yes, of course we're forming the gas komano, we're forming oxygen in the end. So I think of all the ways we can think of when we should come up with oxygen, I think electrolysis can also be one of the ways, because from this principle that we've just looked at here, oxygen can be formed. But then for you to form that oxygen on the other side, but then there must be a way you should be collecting that oxygen. Okay, for that to happen, for that oxygen to be formed, we need to make sure that halide ion in a diluted form. Those hydroxide ions should be the ones to give away the electrons to form oxygen. Okay? Do you know, this whole principle that we've just looked at, since it was like, not like, a giveaway, in this case, we're going to have, let's say sodium, which is forming, okay? It is sodium that is going to be formed. No. The oxygen that will be formed. In this case, chloride, gas, something like that. It's bromide gas which will be formed. No. There must be some conditions that have to be met for there. And the whole thing, there is preference as to which one should be formed. That's why the principle, the preferential discharge. Okay? Because ku anode kuja kapena ku cathode iso zikumakha kwena kuti zikumachita kusankha kuti this one should come and this one should not come. So that's preference. So preferential discharge, because the charges themselves akupeza kwena kuti akutani zikuchita kusankha kwena this one, not this one, depending on those things. If it is the metal or if it is the positive charges, when it's a matter of reactivity. If it is on the negative side, we know it's a matter of concentration and all that. That's preferential discharge. So in the next lesson, what we're gonna have is demonstrate what really happens if you're to have a setup. So just want to put it in a practical sort of aspect. Like the theoretical part of it, right? So let's be there in the next lesson, guys, and let's keep on studying. And wherever you feel like you have questions, let me know so that I should also clarify right on time. Thank you.